Good morning. It's 5 o'clock in the morning. What are you doing? I can't seem to. There it is. Alright, so the pen's not working great, and I'm not feeling good, so this should be one of your better videos ever. Apparently, all that tiredness yesterday was me getting sick, but a bunch of you shamed me into doing this video, so here it is, and you're going to have to listen to me and all of my whininess, and of course, probably going to stop and get an extra cup of coffee. Alright, let's see how we can do with this problem. Emily is late to class 3 out of 4 times. That's my good English. She has 8 classes. What is the probability she will be late to exactly 3 classes? Now, what I probably should have put on here is Lydia is late to class 3 out of 4 times, not Emily. That's kind of silly. So this is one of those, got N, which is, we're going to go 8 classes. R, since this is exactly 3 classes, we'll go right with 3, not with anything else. The probability that she's late is going to be 3/4. And then the probability that she's not late is clearly then 1/4. And we just got to write our equation. So our equation will start with 8CR, 8 things. We're going to choose 3 of them. The first parentheses goes the probability that she will be late, or the P value, in this case, the thing that we're looking for. And remember, that number goes here. And then these two have to add up to 8. So this has to be a 5. And a 1/4 goes here. So I come over to my calculator. And I go into menu, 5, 3. I've got 8 things. I'm going to choose 3 of them. First set of parentheses was a 3/4. So control division 3/4. And I believe that was cubed. Yes, it was. And then, oh no, look at that. I'm still in parenthesis mode, or I'm still in exponent mode. There we go. Parentheses, control, division, 1 out of 4, 1 out of 4. This video might take forever. Fast forward if you already got this. To the 5th power. And I get 189 over 8192. So 189 over 8192. And I think if you put this in your calculator and you round, I'll stop rounding. It's like 0.02307, something like that. Alright. Problem 2 is a fair coin tossed 4 times. There's our N. What's the probability of obtaining at most 1 head? So when it's an at most or an at least or something like that, we've got multiple events to do. In this case, our N is still 4. But our R is going to be at most 1. That means I can get 0 or 1, but nothing more than that. The probability of getting a heads is 1/2. The probability of getting a tails is 1/2. So I've got, because of this, I have 2 equations to write. I've got 4C0 and 4C1. The parentheses, the good news is they'll always be the same for these because they're all 1/2, 1/2, 1/2, 1/2, 1/2. Anybody else bored of saying that? And again, remember, you know, this number goes up here, 0, and the other one goes here because they have to add up to 2. And in this case, it's going to be 1 and 1. So I'll come over to my calculator, wherever. There we go. My calculator. I'll do menu 5, 3. 4C's. I totally forgot what was there. 4, 0. Parenthesis, control, division, 1 over 2 to the 0 power. Did I need to put that 0 power? No. But I'm going to use this on my next one, so I might as well. 1 over 2 to the 2 power. And I get, what the heck? Because I put times 2 here. I blame, I don't know, somebody. Let me get my parentheses back. Parentheses. Let's see if I can actually get an exponent on this thing. Squared. 1/4. I knew that was wrong. Alright, hopefully you're looking at it going, wow, why did he do that? Let's go back to my answer key. I think I put something wrong over here, but let's check. Yeah, remember, kids, even though I was saying it, I'm not doing it. These two have to add up to 4. These two have to add up to 4. Well, clearly I didn't do that. So, let's get that in there right. This should be a 4. This should be a 3. Man, what am I doing? Should have stayed in bed, except I went to bed last night at 8 o'clock, and I got up at 4:30. So that's like a lot of sleep. But I didn't sleep very good. So let's change this to a 4, which is what it's supposed to be. 1/16. That's what I was looking for. And then the next one's going to be a 3 and a 1. So let's go over here. Oops, gosh, darn it. Let's change this to a 3. And then go ding, 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 ding. And then change this to a 1. But don't forget, you got to change this to a 1, too. And hit enter, and I get 1/4. Okay, I knew that one was supposed to turn out to be 1/4, not the other one. Where am I doing in this? So this is 1/16, and this is 1/4. 1/4 is really 5/16. So if I take these two and add them, I get, or 1/4 is really 4/16. And if I add the 1/16, I get 5/16. And if you get the decimal, it's 0.3125. If you remember correctly, I think we went over this in class, standard deviation squared is equal to variance. That's my cool way of saying variance, but variance. So to go backwards, we just take the square root. So the answer to this question is just the square root of 16. It is equal to 4, and that's the standard deviation. Anytime you see these words right here, normally distributed, then what we're looking for, hold on a second. Sorry, kids. Had to take care of some business. Yeah, some business. Alright, so what we're looking for when we do the normal distribution curve is this thing that looks like this. Hopefully yours doesn't look like a wart. Too much. A normal distribution curve. That's close enough. The mean always goes in the middle. In this case, it had a mean of 60. And it's got a standard deviation of 5, so we'll go down 5 to 55 and up 5 to 65. Forgot something. I forgot something that we're going to need. Our reference table. Alright, so I went one standard deviation to the left. Alright, I thought I was going to... I should... I don't know. I thought I was... I don't know. Whatever. I thought I was going to be able to write in here, but apparently I'm just modifying this document. So do you see this link right here? Do you see this 1? Do you see this 1? I went 1 to the left. That means I have to add up all of this stuff. You know what? I really want a good copy of this, so let me do this real quick. I'm going to print this to OneNote. Print to OneNote. Click OK. This way I can mark the heck out of this thing up and I can show you maybe a little bit better what's going on. Just clicked on something else. Let's close that. Oh, it's going to be one of those days, children. And I got a chaperone tonight. Wee, looking forward to that. Let's go. Let's get this in there. And we'll go over here. We'll click on this. Call it the form sheet. Can't do anything. Rename. Formula sheet. Sheet. Sorry, got too much crap open. Alright, so there's my formula sheet. We'll get page width. So, what I actually did was, now that I can probably hopefully draw on this, is I went one standard deviation to the left, one standard deviation to the right. Remember, these are only half standard deviations. So when I went one standard deviation to the left, I had those. When I went one standard deviation to the right, I had those. So what I need to do is add up these numbers, which should be something you should have memorized by now. So when I add those up, one standard deviation to the left, one standard deviation to the right, that's all in this spot right here, I get 68.2%. Alright, next question. In a normal distribution, bam, done. Now draw a normal distribution. 95.4% of our scores fall between 40, that's a lot, and 60. So I go over to my formula sheet. Let's erase what's there. Just gonna keep marking this thing up. So I go to my formula sheet. Now I know that when I add this plus this plus this plus this, I get 68.2. Well, then I'm going to add in a 9.2 and a 9.2. So I come over to my calculator. That's not my calculator. Come over to my calculator and I go, okay, 68.2 plus 9.2 plus 9.2. I get 86.6. I'm not where I want to be. I want to be at 95.4. So I'm going to add in this 4.4 and this 4.4. So plus 4.4 plus 4.4 equals, there it is, the magic 95.4. So 95.4 is 2 standard deviations below and 2 standard deviations above. So when I go back over to my sheet, I know that this was 1 standard deviation down, 2 standard deviations down, 1 standard deviation up, 2 standard deviations up. That means right smack dab in the middle is our mean of 50, so x bar equals 50. And since this is 2 standard deviations to go 10, 1 standard deviation is 5. So in a test scores, here we go, normally distributed again. With a mean of 85 and a standard deviation of 5. So how many scores fall between 85, going this way, and 92.5? Well, if I keep going up another standard deviation, this would be 95, right? Yeah. So I didn't want to go up 2. That would be 2 standard deviations. So I want right here. Isn't right here 92.5? Isn't that smack dab right in the middle here? So I want this area, and I want this area. Well, if I go back over to my formula sheet, and I want to go up 1.5 standard deviations. I want to go 1 standard deviation and a half a standard deviation, because I went up from the mean to 1.5 standard deviation. So when I add all those up, 19.1 plus 15 plus 9.2, you'll end up with 43.3%. So I know it's 43.3%. Alright, so I just take 90 kids and I multiply by 0.433. 0.433 times 90 gives me 38.97 kids. 38.97. Well, that's really close to 39. So I would expect around 39 kids to be in that area. Alright, write a rule. So we either got an arithmetic sequence or a geometric sequence. If it's arithmetic, I should be able to add something to go from here to here, from here to here, from here to here. I can't add a number to go from 2 to -8 that also goes from -8 to 32. That just doesn't make any sense. So it's got to be a geometric. So let's see if we can figure out what this ratio is. The ratios will be the second term, A2, divided by A1, which is -8 over 2, which is -4. Or it could be A3 over A2, which is 32 over -8, which is still -4. So my R value, or my ratio between the two terms in this sequence, is -4. Well, then I have to go back to this formula. A sub n is equal to A sub 1, the ratio, n minus 1. Again, I'm just looking for the rule. So my answer, A sub n, is equal to, my first term is 2. I've just found the ratio to be -4, n minus 1. I told you this was an arithmetic sequence. What I didn't do is tell you that I want you to write the rule, which is what I should have put in directions, but I didn't. So since it's arithmetic, I'm going to use the formula A sub n is equal to A sub 1 plus n minus 1 times d. Well, A sub 1 is 42, and d is 6. So this is a kind of uneventful question. A sub n is equal to 42 plus n minus 1 times 6. Well, if I distribute, I get A sub n equals 42 plus 6n minus 6, which gives me A sub n is equal to 6n plus 36 when I clean it all up. All right, page 1 is done. And pages aren't a stupid thing. I'm not doing all the questions. I'm only going to do the hard ones. Just don't have the energy. Oh, Mr. Krause, do you tell me I got to write all these up because it looks really difficult and I don't really want to do it? Shut up. Don't make me mad. You start with n equals 1. Why? Because it tells you to start with n equals 1. Let me highlight it in a blue circle and some highlighter. And we're going to end at 10. You mean I got to write 10 of these, Mr. Krause? And we're going to plug it back into this equation. Are you kidding me? Oh my gosh, you're redunculous. 2 times 1 plus 1. 3. 2 times 1 plus 2 times 2, because we're going to now use n equals 2, plus 1. 5. Now we're going to use n equals 3. 2 times 3 plus 1. 7. 2 times 4 plus 1. 9. 2 times 5 plus 1. 11. 2 times 6 plus 1. 13. 2 times 7 plus 1. 15. Notice they're just the odds. 2 times 8 plus 1. Okay, I can't count. 17. 2 times 9 plus 1. 19. 2 times 10 plus 1. 21. Let's see. If I put these two together, I get 30. If I put these two together, I get 30. If I put these two together, I get 30. Well, that's 330. There's 90. And then 15 and 10 is, I don't even know, what's that? 25 plus 12. That doesn't even make any sense. I must have screwed something up. 21 and 9. You add them all up, you get 120. 1, 2, 3, 4, 5, 6, 7, 8, 9. I feel like I've missed something. 10. Whatever. But the other thing is, and you're going to be able to do this on Monday, is to come over to your calculator, go into this button, on the summation button, and down here you'll put N, 1, 10, and then 2, N plus 1, hit enter. Oh yeah, it's 120. I got it right. I feel so good about myself. Yay! All right, IQR. IQR is defined as the third quartile minus the first quartile, or Q3 minus Q1. And that is 8 minus 3, which is 5. Don't fall for the one that says, oh, the range is from 3 to 8. No, 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 no. It's a number, how spread out the data is. I think I put survey here, response bias here. Let's go down here. Oh, this is a tough question. There's 16 flavors. There's 3 syrups. And 7 toppings. All right. Well, to find out how many different ways you can do that, you just multiply those together and you get 336. Done. I think we went over this one in class. At least I did parts. There's 6 starting players. I got to do 3 girls and 3 boys. I have 7 boys to choose from and 6 girls. So what I need is 3 boys and 3 girls. Well, 3 boys, there's 7 of them. It doesn't matter how I pick them because they can play any position they want. So I've got 7, I'm going to choose 3. And is multiplication. I've got 6 girls, and I'm going to choose 3 of them. Well, 7 choose 3 is 35. And 6 choose 3 is 20. And I multiply those together, I get 700. 700 different ways of picking those kitties. All right, so there's a few ways of doing this problem. I've got a batting order, and I've got 9 players. But the pitcher definitely wants to go last. So I could do it a couple of different ways. I could say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I could say, look, I want the pitcher to go last, so I only have one choice for this. And then really what I want to do is think about this order. Well, there's 8 kids left for this one, 7 kids left for this spot, 6 kids, 5 kids, 4 kids, 3 kids, 2 kids, and 1 kid left. So that would be 8 factorial. Or I could go about it saying, okay, I want the pitcher to go last, so that part is done. I've got 8 spots left, and it makes it different how we put the batting order together. So if I've got 8 spots left, that's 8 kids and pick 8, because order matters. So either way, you'll get to the right answer. I can either do 8 factorial, and I would get 40,320, or I could do menu 5,2, and then do 8 comma 8. I still get 40,320. It's the same thing. So 40,320 ways, believe it or not, of picking that order lineup. Riff raff. There are 8 letters in riff raff. So I'm going to start with 8 factorial. Now, if they were all different, my answer would be 8 factorial. They are not all different. I have two r's. So I need to divide by 2 factorial for, this is for the r's. And then I've got 1, 2, 3, 4 f's. So I've got to multiply by 4 factorial for the f's. Let's see, got the r's, got the f's. The only thing left is an a and I. So if I go to my calculator and I say, okay, control division, do your magic, 8 factorial divided by 2. I don't really need to put in 2 factorial because 2 factorial is really just 2, or 2 times 1, times 4 factorial, enter, and I get 840 different ways. Sorry. Determine the mean and standard deviation of the data. Well, the mean's really easy. It's right here. X bar is equal to, and it's around to the nearest hundredths. So 5.43. And because this did not say the word sample anywhere in this problem, we're going to use this, our population standard deviation, sigma x, and that's 2.44. So if my data is on a range, I need to figure out, here's my mean, which is 5.43. Now I'm not going to draw the normal distribution curve because I just looked and it doesn't say normal distribution. Eventually it says, is it normal? And we're going to have to make that determination. So I go up 1 standard deviation. When I add, I can't even read my own right. Well, it's too faint. So when I add 5.43, so 5.43, and I add 2.44, I get 7.87. So 7.87. And when I subtract, oh, it would have been easier just to type it. When I subtract, I get 2.99. And I actually knew that. 2.99. So I want to find all the scores in my list over here that are between 3 or 2.99 and 7.87. So that's between, that's between, that's between, and that's between. The 8, and the 1 are not. So the answer to the first part is there are 4 scores within 1 standard deviation. But then the next question is it normal? Well, let's see what that represents. 4 out of 7 represents, if you do it on your calculator, about 57.1%. If it was to be normal, I would expect this to be 68.2%. This is not even close. So the answer to this question is no, this is not normally distributed because it's not close enough. And just putting no, by the way, is not. What you need to put on there is no, it is not normally distributed because it's not close enough to 68.2% in order to be considered normal. Miss Harris has 3 days off from work this week. The probability it will rain is 2/5. She's got 3 days off, and we want to know at least 2. So we'll go back to what we were doing before. N equals 3. R equals, well, at least 2 would be 2 or 3, excuse me. The P, the probability it will rain, because we're looking for rain, is 2 out of 5. The probability it will not rain is 3 out of 5. So we need to create 2 equations. We need to create 3 choose 2 equation and 3 choose 3 equation. I don't know why I put that. It should be times. And then 2/5 goes here. And 3/5 goes here. Oh, this 2 goes up here. So this 2 goes up here too. And then they have to add the 3, so I'll put a 1. I think I got that right this time. And this 3 goes here, and I'll put a 0 here. If I go over my calculator and I do this crazy math, menu 5, 3 gives me combinations. It's 3, comma, I forgot. 2, parentheses, control division, 2 over 5. And this one we want to be squared. Parentheses, control division, 3 over 5. And this one we want to be to the first power. So I could put to the first power. I can just leave it. Boom. 36 over 125. Let me write that down. So the first one is 36 over 125. And we're going to add to it whatever the second one is. So it's the same thing, except this is to the 0 power, so I don't really need that anymore. And then this one is to the 0 power is 1, so I can just get rid of it. This is 3, and this is 3. And it makes a huge difference that you actually change those, and you get 8 out of 125. So 36 out of 125 and 8 out of 125 is 44 out of 125, or 0.352 something. Let me see. 36 out of 125. 36 divided by 125 equals, ow, you son of a point, what? Oh, 44 out of 125. Doggone it. Control division, 44 decimal divided by 125. Oh my god. 125 is 0.352. Alright, so what we got here is we got a target this big. It's got a radius of 9. So the area of this is, remember what I told you, you're going to be doing areas almost all the time. The one with this is 81 pi. Pi r squared. R squared would be 81, so 81 pi. Then I'm going to come in and put in the bullseye. Well, the bullseye's only got a radius of, wow, it's an amazing circle. The bullseye's got a radius of 3. So the bullseye, its area is 9 pi. So the question is, what is the probability I land in this spot out of the whole entire thing? Well, there's the whole entire thing, all of this in here, right? And I want just the bullseye. Well, that would be simply then, so the probability of bullseye is 9 pi over 81 pi. Well, I hope you know that that reduces to 1/9. So that's the first part of the problem that you had to do. You had to figure out that was 1/9. That was kind of a pain in the, we'll call that a pain in the Torres. You know what I'm saying? Yeah. So now let's see what we got here. Now what we want to do is we're going to throw 5 arrows at this thing, and I want to hit it at least 4 times. So not only did I have a complicated area question to figure out, which wasn't that bad, now I got to figure out, see, I'm going to get a little more animated, got a little more coffee in me. Now I want to figure out this probability. So like I didn't just do this one where I just give you the probabilities and you got to go. I've actually made you do a little work. It's because I don't like kids. I only got in this profession for the money. I mean the vacation. That's it. Just kidding, kids. Oh, you guys are amazing. So 5 there. I want at least 4, so that would be 4 or 5. Probability of now of a bullseye, I know, is 1/9. I have a 1/9 chance of getting a bullseye, so therefore the probability of not a bullseye, which is more likely, is 8 out of 9. So 5C4 is my first equation. 5C5 is my second equation. In my parentheses are going to go 1/9 and 8/9. And we got a 4 here and a 1 here. 5 here and 0 here. So come over to my calculator. I go menu 5 3 and this was 5 comma 4 parenthesis control division 1 over 9 parenthesis or up raised to the 4th parentheses. I'm going to actually put the exponent on. I didn't like the fact that I didn't do it last time because it kind of messed things up a little bit. So 8 over 9 raised to the 1th, which is kind of boring. Well, that's not what I got before. What did I do wrong? One over 9 to the 4th, 8 over 9 to the 1st. I'm gonna just put it in my calculator wrong. That's that's 40 over. I don't know what I did before. That's 40 over 59. So my first one is 40 over 50,049. No, it's not. Oh my gosh. So it's 40 over, maybe I even have that number, 59,049. 59,049 plus, this becomes a 0, or I can just delete it. This becomes a 5. And this becomes a 5. And this is 1 over that. So plus 1 over 59,049. So my answer is 41 over 59,049, which is really small. Variance. If you remember, variance is equal to the square. The variance is equal to the standard deviation squared. Standard deviation squared is equal to the variance. So if I take the square root of the variance, I get the standard deviation. So the answer is 2. Normally distributed. There we go. Back to normally distributed. We got a mean of 500 and standard deviation of 40. Let's just take care of that business right now. Draw our wart, right, Hawk? Oh no, it wasn't you. It was somebody else that drew the. Who drew the warts? Somebody else drew the warts. Somebody in my like 4th set class, I think. I don't know. So my average or my mean is 500. I have a standard deviation of 40, so that would be what, 460 and 540. All right, but that's not what we want. We want 420 and 580, so I got to keep going. Luckily for me, that's just another full standard deviation down, 420, subtracting another 40, and then add another 40, I get to 580. So really, in effect, what I've done is I've gone 2 standard deviations to the negative and 2 standard deviations to the positive. And what percent of students scored between that? Well, if you remember from before, you should know what that is. But if you don't, remember, we got to go 2 standard deviations below and 2 standard deviations above. And so what we want is all of this. All of this. Well, I add all those numbers up, and you get 95.4%. We'll delete this for later. So 95.4% if you add all those numbers up. I don't know why I went there. That's not where I want to go. This is where I want to go, and I want to go here. And if I add them all up, I get 95.4%. Is this thing almost over? Oh my gosh, Kraus, you give too much homework. Right, Jordo? Normally distributed. Doom. Gonna do it. Gonna do it. Gonna do it. 68.2%. Boy, that sounds familiar. Fall between 80 and 100. Well, if you remember correctly, that's 1 standard deviation below and 1 standard deviation above. 68.2. If you don't believe me, come over and add up these. That is 68.2%. One standard deviation up, one standard deviation down. So, the mean is going to be right smack dab in the middle. So that would be 90. And clearly then my standard deviation would be 10. So the X bar is 90. And my standard deviation is 10. Is that it? Is that all there is to that problem? Good. Rock on. Normally distributed. Here we go again. Wow. This sounds like it's a theme going on. Let's see what I got in this problem. Mean score of 78.4. Let me throw that puppy in. 78.4. With a standard deviation of 8.4. So I got to add 8.4 and I got to subtract 8.4. Well, that one's easy. 70. This one's not so easy. 78.4. I think it's 80. So 78.4 plus 8.4. I think it's 86.8. So 86.8. That's weird. I want to get to 91, so let me add another one. So plus 8.4, 95.2. 95.2. I want 91, so 91 is somewhere in the middle. I really hope it's exactly in the middle. Let's see. If my standard deviation is 8.4, then half a standard deviation would be 4.2. So if I come back up here and I say, oh, let me take this 86.8 and add 4.2. Let's see what I get. Oh, look at that. I get 91. So right there is 91. That's 1.5 standard deviations up. Oh, wait, I want 74.2. Oh, that's down a half of standard deviation. Wouldn't it make sense that this is 74.2? So really what I'm going down a half, minus 0.5, and I'm going up 1.5. Now that's not from the middle going out 2 standard deviations. Let's see what we're gonna shade in over here. Let me get rid of all this. Let's figure out what we're gonna shade in. So we're gonna shade in a half down. That's all this. We're going 1.5 the standard deviations down, and then we're going to go 1.5 up. That's all of this. So there's the area that I'm shading. 1.5 up and 0.5 down. So I got to add those numbers together. So that's 19.1. There's 2 of those. So 19.1 times 2 plus the 15 plus I think it's 9.2 if I'm not mistaken. 62.4%. Yeah, 62.4%. That's what I want. So I have in that area 62.4%. Now, I'm not sure if I'm done. If there's 240 students who took the final exam, approximately how many students would I expect to grade? Oh, so now I have to take 240 and multiply it by 0.624. So 240 times what was it? 624. 149.76. 149.76, which is about 150 students. Geometric sequence. No. What the rule for this sequence? I don't know if this is geometric or algebraic. I got to check. Now, if I take -3 and divide by -7, am I going to get the same thing when I take 1 divided by -3 or 5 divided by 1? Clearly not. So let's try figuring out, let's see if it's arithmetic. Take A2 minus A1. -3 minus -7. That would be 4. A3 minus A2. That would be 1 minus -3. 4. I think it's obvious that I'm adding 4, adding 4, adding 4. So my D is 4. My A sub 1 is -7. So my equation is A sub n equals A sub 1 n minus 1 times D plus. Forgot the plus because this is arithmetic. We have to add. So a sub n is equal to negative 7 plus n minus 1 times 4. When you clean all this up, well, when I distribute, I'm going to get a sub n equals negative 7 plus 4n minus 4, or a sub n equals negative 7. I need a break. Equals 4n minus 11 when you put the negative 4 and negative 7 together. This is a geometric sequence. And they give it to you. This is easy, man. A sub n is equal to a sub 1 rate to the n minus 1. Or a sub n equals 64, which is the first term, r, which is 3 over 2 to the n minus 1. Why did I even put that on there? All right. So I could do this one out. Let me do this one out just because I want to. If n equals 1, so we're going to have negative 3 to the 1th. Well, that's just negative 3. And then we're going to have n equals 2. That's negative 3 squared. That's 9. Then we're going to have n equals 3. That's negative 3 to the 3rd, which is negative 27. And then negative 3, God blessed Jiminy Crickets, and I don't know what's going on here. Oops, switch to red, no cares. Negative 3 to the 4th is positive 81. And then negative 3 to the 5th is negative 243. Well, if I took the time and add those, I believe they add up to negative 183. Or I can come over to my calculator, hit this complicated button, go into my summations. I just said some nations. I think they used n. It really doesn't matter. 1, 5. Now watch what happens if I just put in negative 3 and then I come out here and I go to the nth power. It took the whole entire summation. So you're really going to add 1 to 5, a whole bunch of negative 3's to the nth power. That doesn't even make any sense. So you can't do it like that. So what you got to do is, oh crap. You got to go, oh man, n 1 5. Now everything that you're going to put in the summation's got to go in here. Well, what was in the summation? It was a parentheses negative 3 to the nth power. And so all of that has to go inside these parentheses. And when I do that, I get negative 183. Sweet. IQR for this data. Well, I could just type this data in. I actually was curious what this would look like if I just typed this in. So I'll go here, here. Good. I don't want anybody else's crap in there. We'll call this M for money. And we go 5, 5.25, 3, 3.5, and 4.75. 4.75. And then I'll go in here and I'll go menu, stats, stat calculations, one variable statistics, one list. Call this the money list. Click OK. And then we get our 5 variable stats. And if you remember, interquartile range is the subtraction of Q3 minus Q2. So it's Q3 minus Q1, sorry. And so if you go back over here, Q3 was 5, what? Oh, I had this wrong. I don't know what I was doing on my sheet. 5 point, I forgot what it was, 125 minus 3.25. Did I put those numbers in right? I feel like I put those numbers in wrong. Five, 5.25, 3, 3.5, and 4.75. Whatever. For some reason I thought I had a different answer when I did this myself. So the answer is, I have no idea. 5.125 minus, what were those numbers? 3.25. 1.875. It's weird. Whatever. I'm too tired to think about it. Controlled experiment for 28. Controlled experiment, obviously. Glowworm. There are 8 letters in glowworm. 8 factorial all over. Let's see. There's 1 O, 2 O's. So 2 factorial for the O's. 1, 2 W's. 2 factorials for the W's. W's, these are for the O's. Anything else repeat? Doesn't look like it. And if you put this in your calculator, you go control, division, 8 factorial over 2. I'm just going to do 2 times 2 because 2 factorial is 2. 1080. 10,080. I could put 2 factorial in, but 2 factorial is just 2 times 1, so done. Noah goes to the cafeteria. I don't know why I chose Mac. I just Mac. I don't know. I changed the problem and then go prep Mac. So there are 7 meals and 3 desserts. He wants to pick a meal and a dessert, so there are 21 ways he can do that. There are 15 students trying out for the 7 parts in the play. Each student can play any part. How many different ways can I do that? That is 15, choose 7. So I come on to my calculator, I go menu, 5, 3, 15, comma 7, that should be quite a few, 6,435. So 6,435. Your chores are to cut the grass. You got 5 days, right? 1, 2, 3, 4, 5. Your chores are to cut the grass, wash the car, clean your room, clean the garage, and shine your shoes. You are to do 1 chore from Monday through Friday. You can do each chore on whatever day you want, except you must wash your car on either Thursday or Friday. So this is Thursday. And this is Friday. Gotta get going. Well, let's say I chose this one. I want to do my car washing on this day. Well, that would leave me 4 activities left to do. I would have 4 here, 3 here, 2 here, and 1 here. So that would be 24 different ways. Or I can do my car washing on a Friday, and then I would have 4, 3, 2, 1, and I would have 24 different ways. So if I chose it on a Thursday, I'd have 24 different ways. If I chose it on a Friday, I'd have 24 different ways. I believe there are 48 different ways. Determine the standard deviation. We're getting how many costs fall within 1 standard deviation of the mean. So I go to my calculator, go to my list. Got some more crap in there. Get rid of it. Yes. No. Jeez. No. Calculator. Call this. What is this? Money again. We'll call it M. So, oh my God, it was the same list. 5, 5.25, 3, 3.5, 4.75. Go into menu, stat calculations, 1 variable statistics, click OK, click on the money, click OK. So my mean is 4.3. My X bar is 4.3, and my standard deviation is 0.886, because this is not a sample. So if I take 4.3 and I add 4.3 and I add 0.886, I get 5.18. So the high end will be 5.2, let's say, 5.18, and all the way down to the low end, which would be 3.4. Let's see, all the ones between $3.40 and $5.20. Highlight them. That's over three. Oh no, that's not it. Shoot, what did I get that one for? All right. So 350 is fine. 475's in there, and 525. So there are 3 out of 5. That's 60%. Is it normally distributed? It's close to being normally distributed. If it was normally distributed, we'd expect it to be 68. This is 60. So in this case, I'd probably say no, it's not normally distributed. It's a little too far off. I would expect it to be a little bit closer. Mailing survey forms home to students. A Dropbox complete. No, this has that. Remember when you mail things home to ask people questions, who answers them? You know, it's the bored people at home that got all the extra time. So yes, there is a non-response bias, basically, which means there's going to be a lot of people that don't respond to that survey just because they don't want to or don't have the time. So that's it, kids. Hopefully this helps. Peace out.